students, beloved students, myself Srinivas. Welcome back to Sea Level Physics. Today I am going to discuss some techniques involved while solving sums in case of body projected vertical upwards, body projected vertically downwards, and body dropped freely from certain height. Right? Let's move on to discuss. Right? Before that, we have to know usual representation of body projected vertically upwards. Suppose one body is projected vertically upwards like that from the ground, right? With some initial velocity u, right? Now this is under retardation. Why? Because it is moving against gravity, so its speed gradually decreases, and becomes zero somewhere here the last becomes. So during ascent, body is under retardation. But on reaching highest position, because of gravity, body retraces the same path, like, right? This is the actual representation of body projected vertically upwards. But if you write both arrows on the same line, you may get confused. So to avoid confusion, what shall we do means we have to take two lines, right? This is what line representing ascending motion. This is what line representing descending motion line. So join like that. So this is what usual representation of body projected vertically upwards. Right? Now technique number 1 in case of body projected vertically upwards. See number 1. Here one body is projected vertically upwards like, right? From reference line, usually this what? Ground. So take this diagram into consideration. Now the question is, the particle reaches one point P in its path once at T1, one more time at T2 respectively. See this what? One point P in its path, right? It reaches the same point twice. Once during ascent, one more time during descent as shown. See, this is what actual path followed by the particle line. Right? See, it crossing the given point P twice. Once at during ascent, one more time at during descent. Now the times are like that. See, this is what time T1. Now this is what time T2 like that. So time T2, right? Now what is the remaining path here? This is what remaining path. Okay. Now see, this is what actual representation of body projected vertically upwards. Now the question is, the particle reaches one point P twice. Once at T1, one more time at T2 respectively. See, both times T1 and T2 are measured from the initial instant itself. See, while going up from point, suppose this point of projection, from the point of projection, first time it reaches P at T1 seconds, one more time at T2 seconds. Now both times measured from the point of projection, right, as shown. Now the question is, what is the initial velocity of projection? What is the initial velocity of projection? Number 1, question number 1. What is the question? Velocity of projection, question mark. Here velocity of projection is not given. First question is, what is the velocity of projection? Now how to find velocity of projection in this case? Now if you observe carefully the diagram saying that time of flight. See, from time taken to reach P from point of projection, initially T1, right? Afterwards one more time T2 seconds, right? So here question is, particle reaches some point P at T1 and T2 respectively. Means both times are measured from the initial instant itself, right? From T equal to 0 itself, right? Now on seeing carefully, now this is what time taken from here to there to go like this. For this segment, what is the time taken? T2. For this segment, T1. So if there is no air friction, time of ascent equal time of descent. We came across that point. Suppose to go from here to there, if it is T1, to go from here to there also T1. So while going up, if it is taken T1 time, T1 seconds, while coming down, the same particle takes T1 second only, right, to cover the same distance. So here also, to go from point of projection to P, T1, from P to point of projection also T1. This is also T1. This is also T1. Am I right? See once again, suppose this is point of projection O. What is the time taken to reach P from O directly T1 during ascent? During descent from P to O, what is the time taken? T1. Why? Because time of ascent equal time of descent. In case of there is no air friction. So what is the time of flight here? Time of flight capital T equal to, see carefully. Here it is T2, here it is T1. If it is T1, this is also T1. So T2 plus T1 is the time of flight. T2 plus T1 is the time of flight. That is T2 plus T1 means T1 plus T2. What is the usual expression for time of flight? Time of flight equal to twice velocity of projection by g. Am I right? We came across already. That is twice velocity of projection by g. Right? From which u can be written as u equal to 2 by g becomes g by 2. That is half g T1 plus T2. Half g T1 plus T2. This is what? Velocity of projection. Velocity of projection in terms of T1 and T2. T1 and T2. Right? Number 2. What is the velocity with which particle reaches point P? Velocity at point P is question mark. Number 2. Right? Now take the segment OP. Take the segment OP like this is what O, this is what P. Right? Here question is velocity at P is to be found. That is Vp is unknown. Now take V equal to U plus A. That is we know that V equal to U plus AT like. Right? So A is what? Minus G. Why? Because this is our reference line. G is acting vertically downwards. Right? So V equal to U plus AT. V equal to U plus AT. Already we know that the U value. So V at P, V means V at P, that is equal to U means half G T1 plus T2. Half G T1 plus T2 plus A means minus G into what is the time from O to P, that is O to P means T1. So T1, right? That is V at P equal to half G T1 plus half G T2 minus G T1, right? That is V at P equal to, same can be written as, let's see, object T1 minus GT1. Object T1 minus GT1 means minus object T1 minus half GT1 plus object T2 plus half GT2. Object T1 minus GT1 means minus object T1 plus object T2. So half G is common here, half G is common, that is T2 minus T1. T2 minus, so this is what number 1, this is what number 2. So the first question, velocity of projection is calculated. The second question, velocity at point P is also calculated. Half G T2 minus T1 in terms of T1 and T2s. So here also in terms of T1 and T2, here also in terms of T1 and T2, right? Now coming to third question. What is the third question here? That is height of the point from the ground. Height of the respective point P from the ground. Question number 3. To to find height of the point P from the ground, right? Now take segment OP. This is what segment OP, right? So here S equal to HP. Why? Because this is our reference line. Okay, T equal to T1, A equal to minus G, right? Now take S equal to UT plus of AT square. Now S means height of point P, HP equal to U means what is U of G T1 plus T of G T1 plus T2 into T means T1 plus of into A means minus G into T means T1 square. I'm wrapping off. See here, S means HP equal to U means what is U of G T1 plus of G T1 plus T2 into T means T1 plus A means minus G into T means again T1 square, like, right? Extend, that is of G T1 plus of G T2 plus of G T1 and T1 square plus of G T2 into T1 means of G T1 T2 plus or minus of G T1 square. Okay. Now of G T1 square minus of G T1 square cancel. We left with of G T1 T2. So this is what HP. Height of point P equal to of G T1 T2. Right? This is what number 3. Number 3. Right? So in first case, velocity of projection is calculated. Second case, velocity at point P also calculated. In third case, height of point P from the ground also calculated. Now, question number 4. Maximum height reached by the body above the ground. Maximum height is unknown. H maximum is unknown. So what is usual formula H maximum? U square by 2h. We know that H maximum equal to U square by 2h. Direct formula. U square by 2h. What is U? U means object T1 plus T2. That is of G T1 plus T2. This is what U whole square. Right? Right? So U means object T1 plus T2 whole square by 2h. Right? So here whole square is there. So G square by G means G. That is 2 square means 4. 4 to 8. That is G by 8. G by 8 into T1 plus T2 whole square. This is what H max. H max. Maximum height. So G by 8 of T1 plus T2 whole square. So here 4 parameters were calculated: velocity of projection, velocity at point of P, height of point P from the ground, and moreover maximum height from the ground. Right? Okay. Suppose one more body is dropped from point P like that. Second body is dropped from point P like that. Dropped means U0. Right? Now time taken to reach ground is unknown. T is unknown. This is what first body. This is what second body. So second body is dropped from point P and it takes time t seconds to reach the ground. Now what is the relation between T1 and T2? Let us check. See number 5. Point number 5. Suppose one body is dropped like that from point P. Dropped means U0. A equal to minus G. Why? Because this is our reference line. gravity downwards, right? Now question is to find time taken to reach ground, alright? So take S equal to ut plus half 8 square, direct form. We know that S equal to ut plus half 8 square. S means here what? S means height of the P. Height of the P means here already we have height of the P, object T1 T2. So this is what S equal to height of P with the negative sign. Why? Because this is our reference line. Displacement is negative. Why? Because particle moving downwards. S equal to minus HP. Minus HP line. Right? Okay, minus HP. Now S equal to minus HP equal to U0 into T plus half into A means minus G into T square. So minus plus or minus cancel. We left with HP equal to half G T square. This is what number point number 4 here. This is what number 5. Number 5. Now from 3 and 5. From 3 and 5. From 3 and 5. See equation number 3. Height of point P from the ground is object T1 T2. Here height of point P is object T square. Equate both. That is object T square equal to object T1 object T1 T2. So object cancel. We left with the T square equal to T1 T2. Now T equal to root T1 T2. This is the required relation. In case of body dropped from the same height P, right? Time taken T in terms of T1 and T2 is given by T equal root over T1 and T2. Suppose if you are given question like that T1 equal 2 seconds, T2 equal to 4 seconds. In this case, now let us check all the answers from first equation, second equation, third, fourth, fifth. Now let us see. Suppose T1 equal 2 seconds. Suppose one body is projected vertical upwards from the ground with some unknown velocity and reaches one point P in its path at T equal 2 seconds and 4 seconds respectively. In that case, find velocity projection, velocity at point P, height of point P from the ground, maximum height raised by the particle. Similarly, if second body also dropped from the same point P, now find the time taken in terms of T1 and T2. Now the question, that is the question, right? Now let us do that kind of sum also, same sum, right? Suppose question is like that. In the previous question, T1 equal to 2 seconds, T2 equal to 4 seconds. Right? In the same sum, you are given numerical values T1 and T2 ones. Right? Now G is 10 meter per second square. 10 meter per second square. Right? 10 meter per second square. Question number 1. What is the velocity of projection? Velocity of projection is unknown. See, U question mark. U means what? Object T1 plus T2. Of G T1 plus T2. That is half into G means what? 10. T1 plus T2 2 plus 4. 2 plus 4 6. 6 into 10 60. 60 by 2. That is 30 meter per second. Right? Number 2. Question number 2. What is the velocity at point P? Means object T1 T2 minus T2. Velocity at P. Question mark. Velocity at P equal to object T2 minus T1. Half G T2 minus T1. That is half into G means 10. T2 minus T1. 4 minus 2. So 4 minus 2 means 2. 2 into 10. 20 by 2. 10 meter per second. Right? Now question number 3. That is height of the point. Question number 3. I am writing somewhere here. Question number 3. height of point. What is height of the point? Of G T1 T2. Of G T1 T2. That is half into G means 10. T1 T2. T1 T2 means 2 into 4. 2 into 4. 2 4 ja 8 into 10. 80 by 2. That is 40 meter. Now question number 4. What is question number 4 here? Max height reached by the path from the ground. That is H max. H max equal to G by 8. G by 8 plus T1, G by 8 into G by 8 into T1 plus T2 whole square. Whole square. G by 8 into T1 plus T2 whole square. That is H max equal to G by 8. 10 by 8 into T1 plus T2. 2 plus 4. 2 plus 4. 2 plus 4 whole square. 6. 6 whole square. 36. 10 by 8 means that is 5 by 4. 5 by 4 into 36. Right? 9 into 5. 9 into 5 means 45. So final answer is 45. That is 45 meters. 45 meters. Right? Here, one body is dropped. For example, one more body is dropped from the same height. Now, what is the time taken by that body in terms of T1 and T2 means root 2 into 4. That is root 8. That is 2 root 2. So 2 root 2 here. So T means root 2 into 4. That is root 8. That is 2 root 2 seconds. 2 root 2 seconds. Okay. So that's about the given sum. Right? Suppose a small modification in the given sum. What is a small modification here? Small modification. Small modification. Suppose body is projected vertical upwards like that from the ground. Projected vertical upwards like that. This is the actual path of the body. Right? Now this time particle reaches one point P twice. Once at T1 seconds, like right? T1 seconds. This time, in next T2 seconds, particle reaches the ground from point P. Like, see, from point P. What is the time taken by the particle to reach the ground? Means T2. Alright? So time taken by the particle to reach P from point of projection is T1. In next T2 seconds, it reaches the ground. Now in that case, what about all these parameters? Velocity of projection not given. Velocity at point P unknown. Height of point P unknown. Max height reached by the particle unknown. Right. Let us. So here also we can estimate the time of flight in this case also. How? Yes. See, this is what the point of projection O. From O to P, what is the time taken? T1. T1, right? T1 like. See, this is what O to P. O to P, T1. P2 remaining T2. Now, what is the time of flight? What is the total time for which body remains in air means T1 plus T2. Am I right? So time of flight T, capital T equal to T1 plus T2. As in the previous case, T equal to T1 plus T2. So no change. So T1 plus T2 is the total time of flight, which is equal to from formula 2U by G. Same, 2U by G. So that is a 2U by G. Now question number 1. What is velocity of projection? U equal to same. Everything is same. Why? Because time of flight is same as in the previous case, T1 plus T2. Sum of these two times equal to U by G as in the previous case. So in both cases, velocity of projection is same. So if velocity of projection is same, remaining all factors also same. No change. So what about U? U equal to as usual of G T1 plus T2. Of G T1 plus T2. Question number 2. What is question number 2? Velocity of particle at P. That is same. Object T2 minus T. Velocity of particle at P, that is half G T2 minus T. Question number 3. What is question number 3? Height of the point P. See, height of the point P from the ground. H suffix P, that equal to same half G T1 T2. Now question number 4. Maximum height reached from the ground. Same, G by 8 T1 plus T2 whole square. G by 8. Question number 4. Question number 4. H max equal to G by 8 of T1 plus T2 whole square. G by 8 of T1 plus T2 whole square. G by 8. Question number 5. Suppose second body is dropped from point P. Right? Now what is the time taken by that body to reach ground in terms of T1 and T2 means same as usual. That is P equal to root T1 T2. Root T1 T2 as in the previous case. Right? Everything is same. Okay? So that's how one can find different factors in this situation. Okay? Let's move on to the next situation in which you have one tower in all the three diagrams. It is vertical tower of unknown height h. In all the three diagrams we have unique tower only of unknown height h. Here in situation first situation, one body is projected vertical upwards from the top of the tower with some unknown velocity. It takes T1 seconds to reach the ground. In second situation, here one body is projected vertically downwards with the same unknown velocity as in the previous case. Now this body takes T2 seconds to reach the ground. Means this is what body projected vertically downwards with unknown velocity. Right? Here it is body projected vertically upwards with some unknown velocity. Right? Now coming to third situation, from the top of the same vertical tower, one body is dropped freely from the top. Now the body takes T seconds to reach the ground. Now I want to know velocity projection in case of first and second situations. Of course, velocity projection here and there, both one and the same. I want to know velocity projection in both first and second situations in terms of T1 and T2. Right? Moreover, I want to know height of tower in terms of T1 and T2. Right? I want to know time taken by freely falling body P in terms of T1 and T2. Let's move on. See, first case, this is what body projected vertically upwards. Now take S equal to ut plus half h square. S equal to ut plus half h square. Relating all these quantities. Unknown velocity u, time taken T1, S equal to minus h. See here, this is what point of projection. This is what final position. The line segment drawn from initial position to final position, irrespective of direction of motion, is our displacement. So, irrespective of direction of motion, take initial position, final position. The line segment drawn from initial to final is displacement. So, this is what reference line usually. Displacement is from here to there, that is h with negative sign. So, minus h equal to u unknown into time taken T1 plus half into A means minus G. A equal to minus G here. Why? Because G always downwards into T1 square. Right? Now make it subject H equal to minus UT1 minus becomes plus here of G T1 square. Number 1. Right? Okay. Now coming to second situation. This is what body projected vertically downwards with some velocity which is same as the previous case. Now take same formula again, S equal to ut plus of at square, ut plus of h. S means, see this was reference line, S means minus h, because body moving vertically downwards from the reference line. So minus h, u unknown, u, that is what, u also downwards, therefore minus t, t2 plus of into a, again minus g into t2 square. Am I right? So here I'm taking sign convention, u vertically downwards, so negative. Right? So here plus or minus minus, here also minus. So minus is eliminated on both sides, left with h equal to ut2 plus or minus, that is I'm taking negative sign common here negative sign, both cancels, ut2 plus of g t2. Number 2. Coming to third situation, it is a freely falling body. So take the same expression again, S equal to ut plus of at. S means, see this was reference line, displacement minus h from the reference line, minus h equal to u0 into t plus of into a means minus g, once again a minus g into t square, right? That is minus cancel, left with h equal to of g t square. Number 3. Number 1, number 2, number 3. So in all the three expressions we are having height of the tower, right? Now from 1 and 2, from 1 and 2, equate RHS, LHS remains same, take RHS, that is minus ut1 plus of gt1 square equal to ut2 plus of gt square. So from 1 and 2, LHS remains same, RHS also must be same. Now see, T1 is greater than T2. Why? Because your body is projected vertically upwards, your body is projected vertically downwards. So usually T1 is greater than T2. So therefore here of G is common, of G T1 square minus T2 square. Of G is common, T1 square minus T2 square equal to, take this minus ut1 onto RHS, that is plus ut1 plus ut2. So u is common here, t1 plus t2, right? Okay, now this is what a square minus b square form. A minus b into a plus b, that is of g into t1 minus t2. A minus b into a plus b, a plus b. A square minus b square, that is a minus b into a plus b, that is equal to u into t1 plus t2. So t1 plus t2 cancel on both sides. We left with u equal to object t1 minus t2. So u equal to of g t1 minus t2. So this is what required relation. So we have expression for initial velocity in first and second situations in terms of t1 and t2. Right? Now coming to height of the tower. How to find height of the tower means eliminate the term u in first and second by writing object t1 minus t2. See here we have h equal minus ut1 plus object t1 square. Here also h equal ut2 plus object t2 square. So either from 1 or 2 replace u by writing object t1 minus t2. So this is what number 4 for example. Right? Now one implies what is 1, h equal to minus ut1 plus object t1 square plus object t1 square. Now what is u? U means object t1 minus t2, replace. So h equal to minus, u means object of t1 minus t2 of g of t1 minus t2 into t1 plus of g t1 square, right? Okay, now height of the tower h equal to minus half g t1 square, t1 into t1, t1 square minus or minus plus half g t1 t2, half g t1 t2 plus half g t1 square plus half g t1 square, right? So minus half g t1 square plus half g t1 square cancel. We left with half g t1 t2. That is height of the tower equal to half g t1 t2. Height of the tower. Now all the three situations, one tower only, one vertical tower only, whose height is h, that is half g t1 t2 in terms of t1 and t2, right? Now coming to here, I want to know time taken by third freely falling body in terms of t1 and t2. How to find? See here, h equal to half g t1 square, here h equal to half g t1 t2. Equate these two. This is what number 5, for example, from 3 and 5. In 3, RH is half g t square, here RH is half g t1 t. Now h is remains h on. So from 3 and 5, half g t square can be written as half g t1 t. Half g t square equal to half g t1 t. Half g t1 t. That is half g cancel. T square equal t1 t2. T equal to root over t1 t2. Right? T equal to root over t1 by t2. Root over t1 t2. This is what time taken by freely falling body in terms of t1 and t2. Okay, right? Now next situation in which the body is projected vertically upwards like this. Body projected vertically upwards like this with some known velocity u. So u is the initial velocity of projection. Now this is the path followed by the body projected vertically upwards, right? So in case of upward motion, we are considering only upward motion. So this A is what? Point of projection. B is what? B is what? Highest point at which velocity becomes, right? What is the time of ascent here? Time of ascent, let it be n seconds. Means time taken to reach B, highest point B from point of projection. That is n equal to u by g. Right? Here u can be written as n times g. So time of ascent is n seconds. As per mathematical formula, time of ascent equal to u by g, u equal to n times g. Right? U equal to n g. Now the question is, the distance covered by this body during upward motion in the nth second, means last second. See this word, for example, nth second. Right? Sn is question mark. Sn is question mark. What is Sn? Distance covered in last second of upward journey. Last second of upward journey. That is question mark. Here n is the last second of upward journey. 1 second only. Why? Because the total time of journey is n seconds, in which we need to find distance covered in especially last second, that is nth second. Right? What is the formula here? Number 1, Sn equal to u plus a by 2 into 2n minus 1. This is what distance covered in n second, particular second. Right? So u, see this is what reference level. Right? U positive plus a becomes minus g. Why? Because gravity downwards, body moving upwards. So a becomes minus g by 2 whole into 2n minus 1. 2n minus 1. That is u plus or minus g by 2 into 2n minus 1. Now I want to know distance covered in n second by changing u. What is u here? U means ng. Replace u means ng. ng minus, now distribute here, g by 2 into 2n, that is 2 to cancel, minus gn, minus some minus plus g by 2 into 1, that is g by 2. So minus gn plus gn cancel, we left with g by 2, g by 2, that is, g means what? Usually 9.8, otherwise 10 meter per second square. If it is 9.8 by 2, that is 4.9 or 10. If it is g is 10, 10 by 2, that is 10 meters. So here, distance covered in last nth second during upward journey is independent of velocity of projection. Why? Because Sn becomes equal to g by 2, half of the acceleration due to gravity. There is no velocity of projection involved in this expression. Means independent of velocity of projection. So Sn, distance covered in last second of upward journey, is fixed, that is g by 2, independent of velocity. So independent of velocity of projection. Velocity of projection. Right? Now I want to know velocity somewhere here, 1 second before highest point. See, this is the point. Let it be P. Now I want to know velocity at P. Vp number 2. Velocity at P. What is the point P here? That is point. This is the point. Now what is the time taken this point? Means that is n minus 1 seconds. N minus 1 seconds. N minus 1 seconds. Why? Because what is the time taken from A to B means total n seconds. Now for this segment, last 1 second, that is n second. Remaining seconds from A to B, that is n minus 1 seconds. So I want to know velocity after n minus 1 seconds from point of projection. Means velocity 1 second before reaching highest point. Why? Because from A to there, nth second means 1 second only from P to B. From A to P, it takes n minus 1 seconds. So I want to know velocity 1 second before reaching highest point, especially at the point P. Vp is question mark. That is, you know that V equal U plus AT. V equal U plus AT. V means velocity at P. That is, U means what is U here? Ng or Gn. U equal to Ng or Gn. N times G or G times N. Plus A means minus G. G always downwards, so minus into T. What is T? From A to P, what is the time taken? N minus 1 seconds. N minus 1 seconds. N minus 1 seconds. Not n minus 1 second, that is n minus 1 seconds. So that is n times G plus or minus G into n minus 1. That is Ng minus Gn minus or minus plus G. So Ng plus Ng minus Ng cancel. We left with G1. G. So velocity at P. Velocity at P. What is the value? G. What is the value? G. Again, G is constant at a given place. G is constant at a given place. Here also, the expression doesn't involve any velocity of projection. So whatever the velocity of projection, the velocity 1 second before reaching highest point is fixed. That is constant. G1. That is 9.8. 9.8. Otherwise 10 meter per second. Fixed. Constant. Constant means independent of velocity of projection. So whatever the velocity of projection at point of projection, right? The velocity 1 second before reaching highest point in its journey remains constant. That is 9.8 meter per second. Otherwise, right? Independent of velocity of projection. So what is the reference here? Suppose in case of free fall, after 1 second, what is the velocity here? V equal to U plus AT. V equal to U plus AT. Velocity after 1 second equal to V equal to U0, A equal to minus G into T means 1 second. So V equal to minus G. V equal to minus G. Here also V equal to plus G. So during upward motion, during upward motion, right? Last second, just before 1 second, whatever the velocity, whatever the speed here, that is v equal to plus g. During downward motion, 1 second after free fall, what is the velocity minus? Means speed remains same, but velocity not equal. Why? Because velocity means should have direction. So speed is said to be same. So v equal to plus g here. V equal to plus g here. V equal to minus g. Right? So during upward motion, 1 second before reaching highest point is v equal to g. During downward motion, 1 second after free fall, v equal to minus g. Plus g minus g means magnitude same, means speed is same. Right? That's what I want to tell. Okay. So let us see next point. Next situation, here body is projected vertically upwards. In its entire motion, I want to know the distance covered in the last second of its entire motion. See here, this is what reference line means, ground from which body is projected vertically upwards line. It's some known velocity u, right? Your body is vertically projected. Now this is what total path, right? So what is the time of flight here? Time of flight capital T equal to let it be n seconds. Let it be n seconds. Time of flight. That is the total time for which body remains in air. N equal to mathematically 2u by g. 2u by g. Am I right? N equal to u by g. Now I want to know distance covered in last second of entire motion, that is s suffix here. What is the time taken to go like that? Means n seconds, that is 2u by g. I want to know distance covered in last second of entire motion, that is Sn question mark. Sn question mark. How to find? Means very simple, by taking n second form, that is Sn equal to see here, Sn equal to u plus a by 2 into 2n minus 1, right? Okay, now Sn question mark, Sn equal to u means what? Positive u plus a means minus g by 2 into 2n minus 1. Why a is minus g means g always downwards. So that is Sn equal to u plus or minus g by 2 into 2n. 2 into n means what? 2u by g. This time we are replacing n by writing 2u by g. 2 into n means 2u by g. n means 2u by g minus 1. That is Sn equal to u, right? Here 2 cancel, g cancel, u. We left with 2 cancel, g cancel, minus 2u, minus or minus plus g by 2, plus g by 2, right? That is Sn equal to u minus 2u means minus u plus g by 2. But here initially body is moving upwards, but in last second of entire motion means body moves downwards, means we should have negative sign for entire value. So negative sign is kept common here. Sn must be negative, that is negative sign is kept common. Why? Because conventionally body is moving downwards in last second of entire motion. So minus is common, minus of u minus g by 2, right? So I am taking modulus Sn equal to distance covered in n second of entire motion, mod Sn equal to u minus g by 2. Usually this is what? Downwards, see, downwards in last second of entire motion. So here from this expression we can say that Sn equal to u minus g by 2. Here velocity of projection is involved. U means what? Velocity of projection. In previous case, velocity of projection is not involved, means independent. But here, distance covered in nth second means last second of entire motion. In case of body projected vertical upwards, depends upon velocity of projection. Right? Of course, g by t is constant, but you have a choice. Why? Because if velocity of projection increases, this term increases. Therefore, distance covered in last second of entire motion changes, increases. So here depends upon velocity of projection. Velocity of projection. That is initial velocity. Okay, friends. With this, I am signing off. Thank you.